Hey math kids, we're going to look at section 10E, the addition law of probability. And I think we're just going to jump in after we write this down. It's P of B minus P of A and B. Okay, so this is the addition law of probability. It's saying the probability of A plus probability of B minus probability of A and B. Okay, so let's start with example number 12. And we're given probability of A is equal to 0.6. Probability of A union B is 0.7. And the intersection is 0.3, and then we need to find probability of B. So what we can do is just plug them in. This is just a simplification problem. So we're going to take this thing, plug it in here, so we get 0.7 equals this plugged in here, 0.6. We don't know what B is, so probability of B. And then the last thing, take this, plug it in here, and so that's minus 0.3. And then it's just some simple algebra. We can combine both of those to 0.3. Subtract 0.3. So we get 0.4 equals P of B. Okay. Now, in the book, they mention mutually exclusive. And so if two events are mutually exclusive, then the probability of their union is just their sum of them being individual. So mutually exclusive is a situation like this. Where there's no intersection. So if we want to know what this and this are together, we don't have to account for the intersection at all. So once again, that is mutually exclusive. Okay. Okay, so let's move on to the next example 13. A class of 30 students was given a history test. Seven students got an A. 11 got a B. A student is randomly selected. Let A be the event that a student scored an A and B be the event that a student scored a B. Are A and B mutually exclusive? The answer is yes. Because you can't both score an A and a B on a test, and so A and B are mutually exclusive. And so now they want us to find probability of A. So probability of A is simply there were 7 out of a class of 30, so 7 out of 30. Probability of B is going to be 4 out of 30. Oh, sorry, that wasn't a 4, that was an 11. I misread what I wrote. So that was an 11. And so this would be 11 out of 30. And then we want to know the probability of A intersect B, which that's going to be 0 because they're mutually exclusive. Since they're mutually, remember the Venn diagram looks like this. They don't cross at all. So that would be for A and for B. And then we want to know the probability of A union B. Since they're mutually exclusive, we just add these together. So 7 plus 11 going to be 18 over 30. And if we want to reduce that, we just get 3/5. Okay. That's everything for that video. If you need additional help, come